Alright, in this video we're going to do addition, subtraction, and complex fractions. So to start off with, just a quick review of how we work with fractions. Fractions tend to be all students' worst enemy, but if we're going to add or subtract two fractions together, we need to have common denominators. That is the requirement to have adding or subtracting two fractions. We need a common denominator. And further, to expand upon that, when we finally have a common denominator, we add or subtract only the numerators. So we add across or subtract across only the numerators, and we won't touch the denominators in that process. So that common denominator will stay, and that common denominator will be seen in our answer. Alright, so have to be comfortable with that process to do these problems. So here is your first example. So in this example, we're going to do 4 over 3x plus 5 over 3x. And you'll notice right away in this first example, the denominators are already common. They're already alike. So don't have to do anything special. Just go ahead and add across the top. 4 plus 5 is 9. We won't touch the denominators. So we have 9 over 3x. But at that point, you could reduce the fraction. 9 over 3 is 3. So definitely can simplify your final answers after you've added or subtracted. Here's one more for you. 2x over x plus 3 minus 4 over x plus 3. Another nice problem in that the denominator is already common, so I can send that over to my answer. Now I need to do 2x minus 4. So like before, you want to be aware of common terms, like terms. 2x minus 4 we can't really do anything with, so we just got to leave it as 2x minus 4. Those like term rules still apply. In this answer, we can't reduce any further. So that would be one that we could circle as our final answer. So we'll move on to another example. This one we'll need to obtain a common denominator. So we're not going to start off with one. We have to somehow find a way to get a common denominator. So we start off with a big one here. X plus 1 over x squared plus 4x plus 4 minus 2 over x squared minus 4. So to help us identify common denominators, a trick to do is basically factor the denominators completely. So get those denominators factored completely so we can see what one is missing that another denominator might have. So the first denominator factors to x plus 2 times x plus 2. And the second denominator factors to x plus 2 times x minus 2. So at that point, you should kind of see what one denominator is missing that the other one has. The one on the left has two x plus 2's, but it's missing an x minus 2. The one on the right is missing an x plus 2. So that is what we need to add to those denominators. Alright, so I'm going to write it one more time in black here, what is already apparent in either fraction. And then in red, I'm going to write in what they need to be included. The left side needs an x minus 2 multiplied. And if we're not going to change the fraction, we need to multiply top and bottom. That's the only way to not change the fraction. The fraction on the right is missing an x plus 2. So I'm going to multiply top and bottom by x plus 2. So as a result of this, both denominators are the same. They're both x plus 2, x plus 2, x minus 2. Alright, so now that everything is kind of in place, it's just multiply it out. So if I FOIL the numerator on the left, I end up with x squared minus x minus 2. And I'm going to leave the denominator factored for now. On the right hand side, I have 2x plus 4 all over that common denominator. So now that the denominators are common, I can subtract across the top. And I would highly suggest, if you're subtracting, add in parentheses to the numerator that's after the subtraction sign. Because that is going to remind you that that minus sign needs to be distributed to everything in that second numerator. Alright, so when I subtract, that minus sign gets distributed to both the 2x and the 4. Hopefully those parentheses there will remind you of that. Alright, so across the top I got x squared. I got minus x minus 2x for a total of minus 3x. And I got minus 2 minus 4 for a total of minus 6. Then my common denominator again is x plus 2, x plus 2, x minus 2. Alright, so you could leave that as your final answer, even with the denominator factored out like that. But I'm going to multiply it out. So when I multiply x plus 2 times x plus 2, I get x squared plus 4x plus 4. So I need to multiply that times x minus 2. It's a bit of a long multiplication process, but we should have had practice with this before. So we should be able to do this. We'll end up with a degree 3 polynomial, x cubed plus 2x squared minus 4x minus 8. So that is my denominator. When I multiply it all out, that long thing is my denominator. So, with it multiplied out like this, we could take it to our steps of graphing. We could, get the x-intercepts. We could get the vertical asymptotes, what makes the denominator 0. We could get the horizontal asymptotes. So having it multiplied out like that helps us graph. Alright, it's now time for a complex fraction, which is basically a fancy title for a fraction inside of a fraction. So in this big nasty thing, we have some fractions within fractions. So we gotta simplify this. Never really want a complex fraction, never really want fractions in fractions. We can always simplify this. So I suggest working in baby steps. So let's first just focus on the denominator. Let's let's let that be our first area of focus. And let's find a way to combine these two fractions first. So to do that, we need a common denominator. If we compare denominators, x plus 2 and x, what's missing from the left side is an x. And what's missing from the right side is a x plus 2. So that's what I'm going to multiply in to both of these. So setting myself up with that common denominator, I'm going to multiply and add across the top. So I got x plus 2x plus 4. And my common denominator now is x times x plus 2. So when I combine like terms in my numerator, I get 3x plus 4. And I'm going to leave my denominator factored for now. You'll see later on in these problems some cancellation might occur. So leave it factored if possible. Combine like terms, but leave it factored. Because if it's factored like that, you might see some cancellation. Alright, so my original numerator was still 2 over x plus 2. But my new denominator now, what's in this cloud, this bubble, became 3x plus 4 over x times x plus 2. So we're actually in a pretty good shape here. If you have a fraction over a fraction, you're actually in pretty good shape. Because remember what those fraction bars represent. Those fraction bars represent division. So really what I have is the top fraction divided by the bottom fraction. And we've done, fraction division before. So even though this looks nasty, it is just fraction division. That's all it is. So my first fraction is 2 over x plus 2. I'm going to divide by 3x plus 4 over x times x plus 2. So you should be able to recall that to divide fractions, we're going to multiply by the reciprocal. So I'm going to reciprocate that second fraction, and I'm going to multiply. And you can kind of see what I was getting at with the cancellation I was talking about. If you leave it in factored form, you can see potential cancelizations. There's definitely an x plus 2 and an x plus 2 that can cancel. So that will help you with your simplifying of the answer. So we got 2x over 3x plus 4. That would be our final simplified answer. Okay, I got one more problem for you to go through today. Again, another complex fraction that looks troublesome, but if you take it in baby steps, we're going to get through it. So focusing on just the numerator for now, I'm going to factor x squared minus 9 because that's going to enable me to see what's missing from either side. What's missing from the right side fraction is x plus 3. So in red here, I'm going to multiply that in my x plus 3. That's getting myself set up with common denominator. So my common denominator is x plus 3 times x minus 3. And on top, I got 4 plus 2x plus 6. Don't forget distribution. 2 times x plus 3 is 2x plus 6. Okay, so what I'm set up with, if I combine like terms but leave it factored, is 2x plus 10 all over x plus 3 times x minus 3. So that is going to be my numerator. Okay, so we just got to do a similar process to this denominator. I got 1 over x plus 3 plus 1 over x minus 3. In red here, I'm going to add in or multiply in what was missing. Missing on the left is x minus 3. Missing on the right is x plus 3. So that gets us our common denominator again. So I got x minus 3 plus x plus 3 all over x plus 3 times x minus 3. So combining like terms, that's 2x over x plus 3 times x minus 3. So that's going to be my new numerator. That's going to go, sorry, that's my new denominator. That's going to go in place of my denominator. So, writing in my new numerator and my new denominator, I'll end up with a fraction over a fraction, which we now know is not that bad. And you're going to begin to identify a special scenario. If in your fraction over fraction both denominators are the same, those are going to cancel every time. So when you start to see that, identify that, just know that's going to cancel. So you can cross those out right away. And to show you why that happens, I'm going to work it out for you. So I got my first fraction divided by my second fraction. In order to divide these two fractions, I got to reciprocate the second part. So that's where it becomes apparent that there's this cancellation. So x plus 3 times x minus 3 is going to cancel. Right, so in the future, if you see that scenario where you have a fraction over a fraction and both of them have the same denominator, know that you can cancel those. Alright, so after the cancellation, we're left with 2x plus 10 over 2x. We're not going to cancel those two x's, right? Because if you recall, there's these bubbles around the numerator and denominator. And if the bubbles aren't the same, we can't cancel. So please don't cancel that 2x. So it would appear this is the final answer. But to go over that bubble idea one more time, we could actually, factor that numerator. We could factor out a 2. So if we factor out a 2 into its own bubble, we're left with x plus 5. And if we factor out a 2 in the denominator, we have 2 and x. So now we've created a scenario in which there are, bubbles that can cancel. Those 2's can cancel. So what you're left with is x plus 5 over x, and that would be the final simplified answer. I'm not going to cancel those x's. Can't do any more cancellation.